All right, so for our first speaker today, as you probably saw on Meetup.com, we have Casey West. So I'm really excited to have Casey give this talk because he's a coworker of mine from Pivotal, and he's going to be talking to you about the minimum viable platform and kind of going into some detail and then diving right in and showing you a platform in action using some open source software that Pivotal spends a lot of time contributing to. So without further ado, Casey?
Hey, everybody. So I need to do some AV action here. I need you all to remind me not to go around this side of the table because we've got like an OSHA situation, and I don't want to get in trouble or fall on my face.
And here I'm remiss. I actually did not take our computer away and line you up with yours.
It's all good. All right, we can see that? Can you see that in the back? We good? Cool. All right, let's rock this. So I want to talk about platforms. Who's heard this word or used it? Maybe even in anger. And you've probably heard, what, like 20 to 200 definitions for what that means? I want to try my best to define it for you very concretely and also demonstrate it for you to really drive the point home. I'm going to turn my laptop roughly this way. So this haiku is written by a coworker of mine. He runs the engineering effort for Foundry, which is an open source platform. And so he says, he wrote this haiku about an operationally mature environment. This is his ideal, right? His ideal state is to be able to say, here's my source code, run it in the cloud for me. I don't care how. How many people live that life right now? Or like literally all you have to worry about is the business value you make every day, and then you can just say, run it and it's fine. I see 0 hands. There are like 270 people here. No, that's not true. There are a lot of folks. So how many people would like to have this life? Like, does this sound appealing? Yeah. And then, whether you're on dev side, ops side, or somewhere in the middle, for this to be true, your life is going to be blissful. It's going to be nice. So I kind of want to show you what it would look like if you did have something like this. Bridget mentioned I like hand-based participation. That's absolutely true. So I'd just like to get a feel for the room before I dive in. I want to make sure that I orient the presentation correctly. How many folks here would say that you identify with being a developer or an engineer? You build something that executives call business value when they talk about it, even though they don't really know what that is. Yeah, that's maybe half of you. And then how many people would say that you're soundly in the operations side? You're responsible for keeping alive the tire fire that first group gave to you. Right. A fewer people. It's always like that. It's a little bit unfair, don't you think? And then how many people say that you live both lives? So you might call yourself a DevOps engineer. Right. You're responsible for everything. You make it, you run it. Yeah. This is probably the right place for you. You've come to the right classroom. You can stay here. So let's talk about this. But firstly, let's talk about one of the most important things. I am Casey West on Twitter, and you can find me and troll me there. How many of you have Twitter? How many of you have heard of Twitter? It's 2016. Twitter anyone? It's a little rough. But you can find me there. You can also see it on the bottom of my slides here. I threw up some helpful hashtags if you do want to tweet about this. Hashtag Docker, hashtag DevOps, hashtag DevOps MSP, hashtag GoTwins or GotWins. Hashtag legit. All right, let's go on. You can also email me if you want to. This is another way to reach me. And then, I write things on the internet, but also there are a bunch more places that you can find me if you go to caseywest.com. So if email is too old of a technology for you, but Twitter is too new, maybe somewhere in the middle is like LinkedIn. But if you're really on the bleeding edge, I guess you could like follow me on Instagram or something if you want. I do work at Pivotal. They let me fly around the world and give talks like this. I'm very thankful to them, so this is my thank you slide. I appreciate that. So I want to talk about this concept of minimum viable platform. I like it because as an acronym, it goes to MVP. And in software, we talk a lot about MVP, minimum viable product. Unfortunately, though, I feel like we spend too much time thinking about minimum and not enough time really considering what's viable. So that's why I've highlighted viable here. So I want to describe what I think of when I say platform at least a minimum set of capabilities to be operationally mature. And you don't have to use software like Cloud Foundry to do this. You can use other technologies as well. You can use Kubernetes, or Mesos and Marathon will get you most of the way there. Like, there's a lot of technologies that you can use and you can sort of piece together to get these sets of capabilities. And that's really your choice. And you can go either way. But I do think that the capabilities that I will demonstrate and that I'll list out here are required for an operationally mature production environment. And I think that if you have these capabilities, or if you're striving to get them, then you can easily call what you have in production a platform. Now, the truth is that everyone has a platform. It's just in various states of disarray. Like, so whatever you are deploying to, even if it hurts you and causes you a lot of pain, that's your platform, right? But hopefully we can get into a world where it doesn't hurt us and cause us pain to deploy to production. Because for as nice as Minneapolis is, and it's one of my favorite places to visit, production is my favorite place to be. Because it doesn't hurt me. So why? So the first thing that you need is fully dynamic DNS routing and load balancing. So when you push an application into your production environment, it should be available. And when you horizontally scale it by adding more instances, it should be automatically routable and load balanced. And this should be, again, fully automatic. If you live in a world right now where you have to email somebody in order to poke a hole in a firewall and give you a DNS entry and probably an IP address, and then also you have to like get yourself into the scheduled maintenance window for your F5 in order to get your stuff load balanced, like that's not automated enough for me. So I'm going to mention that word automation. So if you like working on automation, you can go and work at Target. Thank you, Target. But I do feel like the automation should already be there, right? How well can you say your system is automated if every time you want to do something new, you have to like go and manually change your automation? Like, is that very automated? To me, maybe not. So that's going to be kind of a theme. The automation is already there. So dynamic DNS routing and load balancing, that's one. You need a backing services broker. If you're building an application and it's not a toy, it probably connects and talks to other things. Those other things could be other applications you write if you're using a microservices strategy or a service-oriented architecture. You have these other services. It might be a database, data store of some kind. It could be a caching layer, a message bus, a huge Oracle database, a mainframe. It could be whatever, but you want to connect the applications that you write to other things. And in the classic model of doing this, when you're an application developer, and let's say you want to use Redis as a caching layer, you have to send an email to IT and say, hey, I'd like a Redis cluster. And IT's like, sure, that'll take 6 months for procurement, and we'll get some hardware, and we'll slap that in some racks, and then maybe we'll be able to build this cluster. And then once we've done that, we also have to generate some credentials and tell you how to connect to it over the network, and we're probably going to encrypt that stuff because it's sensitive information, and then we're also going to put it in our ticket, and then maybe we even encrypted that email that went to you. And then, of course, on the developer side, you're like, all right, I got my password in order to connect to my Redis cluster. I'm just going to copy and paste that and throw that right in the code right there. Or if you're maybe a little better than just throwing it in the code, maybe you'll put it into a configuration file that you're pretending isn't really part of your source code. No humans should ever be involved in the generation of credentials in a production environment, ever. This is an automated problem. It's also an automated thing. It's an automated solution. And furthermore, when you're trying to generate or stand up new services, whether it be things like caching layers, message buses, databases, Hadoop clusters, whatever it is, you should be able to do that in an automated way as well. So there's creating and provisioning new services in order to support your infrastructure and your architectural design. And then there's also the generation and management of the credentials and access information. And I think your production environment should take responsibility for the brokering of connections between applications and services, right? Again, that automation should already be there. If you put a bunch of human beings in the middle of an automated process, you make it less automated. So let's not do that. And then we need infrastructure orchestration. So this is very typical. A lot of us know about the IaaS layer, programmable infrastructure, where you can manipulate compute, storage, and networking resources. If you've got programmable infrastructure, you're probably already doing a bunch of this, and that's really good. That can come from public cloud providers like AWS or Azure or Google. It can also come from private cloud or data center stuff like OpenStack or VMware stuff if you're into that sort of thing. But I want to take this a step further. This isn't about having programmable infrastructure. This is about the automation for the allocation of those resources already being there. Right? So not programmable infrastructure, but programmed infrastructure. It should already be done. And if you already have that automation there, then we can talk about this one, which is one of my favorites, which is health management, monitoring, and recovery. How many of you, have a pager or the equivalent of a pager? Yeah, and then how many of you had to wake up in the middle of the night in order to deal with a fire because a VM got lost? Thank you, Amazon. So these things happen, right? You have infrastructure failures, your VMs get lost, your disk goes bust, a server crashes in your data center, whatever. This shouldn't be an outage. This shouldn't be something that takes down or degrades your services. But even more than that, you should have that high availability baked into your system already. But even more than that, your production environment should be able to recover from these types of failures. So if a VM does go missing, your production environment should notice that and replace it. Put that new replacement back in the pool or in the cluster, and then move on with life. It should also emit an event that tell you that that happened, but nobody should have to wake up to deal with it. And that's at the infrastructure layer, but if we move up the stack, you're building applications and you're trying to put them somewhere and keep them alive, your production environment should do its best to keep your applications alive. If you have 500 instances of an app and a few of them are misbehaving or a particular workflow has an exception, it might crash, but your production environment should know that and recover from that, right? I think that's really critical. You also need an immutable artifact repository. In the Docker ecosystem, this would be a Docker repo or Docker registry, where you can build containers, put those containers as close to production as possible. And those containers, of course, are an immutable snapshot, a point in time of your application. And as they're as close to production as possible, this allows you to get one of the major benefits of this whole 12-factor or cloud-native application technique. Who's heard of this 12-factor apps thing? Yeah, most people. If not, go to 12factor.net, the number 12, factor.net. Read all the essays, they'll be very good. But one of them is that you should be able to have a fast spin-up and graceful shutdown. And the fast spin-up is specifically to be able to handle things like auto-scaling or scaling out due to demand. Right? What does your network graph look like if Hacker News finds out that your application is really cool and like a million excited kids go to your application all at once, right? That's a huge spike in your traffic that you want to be able to handle. Well, what is the difference between that and a DDoS? As far as your network is concerned, as far as the influx of requests is concerned, they're almost indistinguishable. And so you need to be able to spin up in order to handle that load, because the truth is that your executive team does not care whether it was Hacker News or a DDoS. They need your application to stay alive, right? So the immutable artifact repository gives us the opportunity to do that. And finally, I think bare minimum, you need log aggregation. If you have a distributed system or an elastic computing infrastructure, then you don't know necessarily where your applications are living on a wide array of VMs, and you don't really have to care. You shouldn't have to care, right? If we believe in this haiku that here's my source code, run it in the cloud for me, I do not care how, then we shouldn't care. But one of the ways that you can choose not to care is that you still need to be able to have the information out of the system that you need. So log aggregation in a distributed and elastic environment is actually kind of a hard problem, but you need to have it solved. You should never have to SSH into production ever again to go searching around on file systems to find your logs that you've been spewing out wherever the developers feel like. That should never happen. So you should have full log aggregation. These are my 6. This is what I think is a minimum viable platform, the minimum required for operational maturity. And whether you're trying to build, buy, or glue a bunch of stuff together, I guarantee you that you have teams, and many of you are probably part of these teams that are trying desperately to get these capabilities in your production environment and to get them fully automated, right? And so with that in mind, what I want to do is demonstrate what your life would look like if you had these capabilities. And I'm going to use some open source software to do that. It's very important to me that you know that it is fully open source software called Cloud Foundry. And let's just sort of jump right into that, but after this. Right, so I want to draw an analogy to make one particular point. You'll notice that in my MVP, minimum viable platform, I don't talk about containers or container orchestration. Who's heard of containers? Anyone? Nobody? Okay, yeah, that was most people. You're probably in the right place. I didn't talk about that, and I want to make a point as to why. So what's the point of having a car, right? And actually, we're here in Minneapolis. I think there are a lot of people who are like, there is no point in having a car, ride a bike. And I agree with them. I do. But if you do have a car, if you do want a car, the whole point of having it is to drive it. It's to get in it and go somewhere, like right away. You don't have just the electrical system of a car or just these other components. You don't wake up in the morning and say, I'm really excited to assemble my car so that maybe I can drive it to work, right? You say, I want to get in my car and go somewhere. Well, I think that this is an important analogy to what we talk about when we talk about platforms. That just because you have containers doesn't mean you have this thing that I would call a platform. And if you're excited about containers, so am I, and I'm super excited about that. But if you build a container, that's adorable, like it's super cute, it's little, it runs real fast, starts up right away exactly when you ask it to, it's really nice, it's adorable. But you can't just go straight from that to like a full-on production architecture conversation for your company just because you had a lot of fun on the weekends somewhere. Like there's some work to do in between, right? And I think we all know this, but you need those lower level infrastructure components, but then you need to be able to provision those resources in order to allocate them to workloads that you orchestrate across that infrastructure. And of course, you still need an interface of some kind, which is what I would consider like the outward pane of glass that a platform typically is. You need an interface, not just for the people that are going to interact with it, but also for the other systems that your software will interact with when it's running on the platform. So I just kind of want to draw that distinction that we're not going to talk about that lower layer. And the truth is, as far as I'm concerned, for systems of scale in this day and age, one thing that we have learned is that containers give you a lot of benefits in order to be able to grow a system and scale it out. And the software I'm going to show you today has been running containers for 5 years. We like containers, I like containers. I just don't want folks to get so focused on containers and container formats when there are a lot of other problems to solve in order to have a production environment. And there's, again, tons of software that can give you these benefits. But think a little bit higher up the stack is what I'm asking. So if we're going to use Cloud Foundry, it comes in 2 primary layers. At its lowest level, there's this concept of BOSH. This is this open source technology, which is infrastructure, it's lifecycle management for distributed systems. So it's infrastructure agnostic. And that was a fancy thing, lifecycle management for distributed systems. But if you think about typical configuration management, usually you're sort of focused on one server at a time. Does this server's configuration match what I expect it to be? Can I converge this server's configuration in order to be what I want it to be? And then you can compile that into a group. The way that BOSH sort of looks at the world is that its primitive isn't a server, it's a complete distributed system. So you orchestrate and manage all of the compute, networking, storage resources that you need for a full distributed system as part of BOSH, and then it's versioned. You can check it into source control. You can do deploys and rolling upgrades and security updates with no downtime and all this fun stuff. So this is like this low level, right? The folks who made this made BOSH. They had worked on Borg at Google. Who's heard of Borg? Handful of folks. It's their container orchestrator that they use in production at Google. They had worked on that, and then they wanted to work on something similar but slightly different, and so they did this weird thing where instead of B-O-R-G, they just incremented a couple of these characters, and because naming and nerds, like we go hand in hand. So then they made BOSH. So BOSH is really good for stateful distributed systems, and one of the stateful distributed systems that we deploy on top of BOSH is Cloud Foundry. So this is the elastic runtime that is containerized that you deploy your applications into. So where BOSH is sort of the operator interface or the IT or platform engineer interface, at Pivotal we have a team that runs a large instance of Cloud Foundry called CloudOps. And if you're searching for a team for your cool new cloud, or a team name for your cool new cloud team, like Steel CloudOps, I think that's pretty neat. Then Cloud Foundry is sort of the developer or application operator interface. This is where you're going to be manipulating the state of the applications that you're working on. And we're going to mostly be looking at this today in order to demonstrate the MVP capabilities. This is sort of this is very architecture, but it's sort of a bunch of stuff that you get out of the box if you use Cloud Foundry. Like when you deploy Cloud Foundry, you get all of these capabilities. And it's also infrastructure agnostic, so you can run it on just about anywhere. So there's a lot of freedom in Cloud Foundry, and all of this stuff is open source, which is super nice. And now I think I'm at the point where I would do a live demo, and I use this gargoyle here because nothing can go wrong when you do a live demo. Nobody else here knows the Wi-Fi password, right? That's good. All right, we can still see that. Cool. So what I'd like to do, as I mentioned, is I want to show you these set of capabilities for your typical life as a developer who wants to just deploy applications. So what I want to do is a little bit of coding. Can you see this here? How about if I do this? Can you see this pony? Yeah? Can you read what that pony said in the back? Can I get a thumbs up? We're good? Mostly good. Good. Come forward if you have an issue. OK. So I've got this very basic app. So let's just take a look at it. We'll take a look in Sublime here. Who's heard of Ruby? Handful of folks. All right, it's a pretty simple programming language in terms of wrapping your head around. I'm going to use Ruby to build a small little RESTful app that I want to deploy to the cloud in order to demonstrate some of these capabilities. So the first thing I'm going to look at here is the gem file. So you can see here that we're going to specify a specific version of Ruby. We're going to specify that we're going to use Puma as our web server and Sinatra as our web framework. And if you're not familiar with the Ruby ecosystem, Sinatra is a very lightweight web application framework, specifically well suited to building small RESTful services or doing demos, both of which I'm doing. And some people even deploy it into production, and I think that's fine. So now let's just take a look at this app. Again, it's very simple. Let's walk through this a little bit. So we're just going to use Sinatra. And you can see here that I'm just going to bind to the special IP address that says I'll listen on any network interface. So in a containerized world, you have an isolated network system. And you don't necessarily know your IP address. And if you care, you need to set it to something. And if you set it to localhost, you won't be able to route outside of your container. So that's not super good. So we're just going to set it to quad 0, which means we'll listen on any network interface. That's a nice little shortcut. But then you can see that for the port, I'm going to bind to the port that's specified in an environment variable called port. So if you think about the 12-factor concepts, one of them is that we should get our configuration information off of the environment. And this, in its simplest form, literally means environment variables. Like, it doesn't even get any easier than that, just environment variables. So that's what I'm going to do here. This is especially important because the Elastic runtime in Cloud Foundry and in most systems, it's going to distribute your applications across a wide set of computing resources, and it's going to allocate your port dynamically to you. And Cloud Foundry will also do things like health checks to make sure your application is alive, and if it's not listening on the port that it expects, then it will assume your application is not working. So we're going to just do the simplest thing we could possibly do, which is to just ask the environment for the port that I should listen on, and we'll listen on that port. I can also do a fallback if I'm in development. I'm not doing development directly on something like Cloud Foundry. Then I can just specify something as a default as well. And then this is our basic web service. At the root of our API here, this endpoint, we will emit JSON. That JSON is very simple. We'll just mention the instance, and then we'll get the environment variable CF instance index. So again, I mentioned that this is a clustered and distributed system. Similar to Kubernetes or Marathon or Nomad, or there are many of these things. Well, at the core, Cloud Foundry has this thing too. And it's going to keep track of the number of instances we're running because we might want to run 50 of them, but we don't necessarily know where they're running, and we don't really care, but Cloud Foundry cares. So it will keep track. So this will be a 0 index number from, say, 0 to 49. So that's very simple, a very, very simple web application. The other thing that I want to show you here, which is sort of Cloud Foundry specific, is this concept of a manifest.yaml. So the manifest is what you use to instruct Cloud Foundry about the operational expectations you have for the application when it's running on the platform. And you can put a lot of things in here, from resource constraints to services that you expect to bind to, et cetera. But I'm just going to keep it very simple. I'm going to state that the name of my application is CFENV, and that I have a memory allotment that I cannot exceed 20 megabytes of memory per application instance. This is neat because, as you might imagine, in a containerized world, this will be a hard constraint. If my application starts to exceed this memory constraint, it will be shut down. The instance will be shut down. Now, Cloud Foundry will notice that and spin up a new instance in its place. So if I have a memory leak, the platform itself will try very hard to keep my application alive, which is part of that automated recovery that we talked about before. And then because this is a super simple Ruby app, I'm just going to tell it what command to run. You just literally run ruby app.rb. And this is all we really need to instruct Cloud Foundry when we deploy this application. So I'm running a local version, a lightweight version of Cloud Foundry on my laptop called PCFDev. It's free. Anyone can download it and run it. You can go to pcfdev.io in order to check it out if you want to. It runs in a Vagrant box. And I also have a small command line utility called CF, which you can see right here. And I'm going to use CF to interact with Cloud Foundry. Now, this is a very lightweight Go binary that wraps around a RESTful controller. And you can see that it does a lot of stuff. We're not going to look into all this because that's way too much. But it's cool that it does a lot of stuff. If I do CF apps, you can see that I don't actually have any apps running, but I am in this application directory right now, and I have my manifest and I have my apps. So what I want to do is actually just deploy this thing. And I could just do CF push and deploy it. So what happens here? With CF push, this will upload our application and our manifest file and do what we call staging. And the stager's responsibility is to build a container for us. So we want to run a container, but we don't necessarily care about how, well, we care about how it gets built, but we don't necessarily want to do the hard work of like building an entire build pipeline in order to manage that ourselves. So what this will do is, it went too fast, is I didn't specify what type of application this is, and out of the box, Cloud Foundry supports a handful of application environments, including Ruby, which is very helpful for this demo. And it notices that this is a Ruby app. It happens to do that by inspecting the fact that there's a gem file. And in the Ruby ecosystem, that's a very common way to know this is a Ruby app. So in order to build the container, it starts with a stock, very sparse Linux file system. And then the Ruby build pack is responsible for putting down the environment that we need in order to run Ruby applications. So it will install a Ruby. It will actually use the gem file to install the version I specify if I specified, or the latest supported version. Then it will run bundle install, because in the Ruby ecosystem, that's what we do. So it'll make sure that all our third-party libraries are installed. And then it'll put our app in that container, and then it'll make that container. Now, I know we're here at a joint DevOps Docker meetup. This container happens to be a format that is called Warden. It's it was started about 5 years ago and is still maintained. It's a slightly different format. It's all the same Linux primitives under the hood. But that's what we do natively in Cloud Foundry in order to run containers. Not to fear, Docker folks. I will also deploy Docker containers to show you what that looks like as well. But you can see that it built a container and then it ran an instance of this application for me. Or at least that's what it said it did. So let's see what happens. If we go to this app, you can see that we are running an instance of this application. And we get instance 0, which is nice. What I want to do here is scale this app up, though. Let's say I want 4 instances. I can just type cf scale, and now I have 4. And I can see what state they're in as well. You can see that they're all running. And if I reload this app, you can see that our instances start to cycle. So we've got this dynamic routing, load balancing DNS. So we didn't have to do anything special to make our app addressable. We didn't have to do anything to make request route to it or for the load balancer to work. It just automatically works. And that was pretty good. The other thing that I can do here is I want to get the logs for my application. So down here, I'm just going to type cf logs cwest cfenv in order to tail the logs for my app. And we should be able to see that working. If I reload the app, you can see that I get logs, and you can see that they're aggregated across the various instances, which are running wherever on different computing resources. I don't even care. So that's not too bad. But this application is sort of a toy. I mentioned in the beginning that if you build an app that doesn't connect to anything, it's kind of a toy. And if you look here, this is a pretty toyful app. It doesn't connect to anything. So what I want to do is I want to take this app and make it enterprise grade. Right? That's a thing that we say whenever we think we want to build good stuff. Like, who here is building enterprise-grade software right now? The few brave folks who raised their hands. Some people were really excited about it. So what I'm going to do is I'm going to take this from a toy to sort of enterprise grade. And you can sort of follow along with me as I do this. Here's what I'm going to do. I'm going to git check out enterprise features. Yeah. Don't be surprised that I'm checking out a branch. Of course I check my code in. I'm a professional. I'm not going to live code. Besides, when I do live code, it's mostly a bug. So here's what we're going to do. We're going to use a few more gems, a very simple utility for Cloud Foundry called CFAppUtils, but also I'm going to use Redis. Now, naturally, and I know that you do this too, I'm going to use Redis as my enterprise-grade data store for this demo. Not actually in real life. I'll use it for my enterprise-grade caching layer, though. It's really good at that. But for this demo, we can use it to store some state, right? Because if we're building stateless applications that we deploy into a distributed cluster, which is what we should be doing, then we can use something like Redis to manage state, at least for this demo. But the whole point of stateless applications is that your state is actually managed externally to the business logic that's running in your application instances. So what I want to do is show you what I mean when I say enterprise grade. Let's go ahead and take a look at this application. What I mean is analytics. I'm going to add analytics because I don't know about you, but anytime I've been in a meeting where somebody says, hey, we just need to add some more enterprise-grade features, I'm like, you don't know what you're talking about. And then I think, what have you probably read about in a magazine recently? I know, analytics. Sure, I'll make it more enterprise-grade by adding analytics. So that's my free career advice to you. When confronted for the need for more enterprise gradeness, say, sure thing, I'll add analytics. Let's take a look at what we're going to do here. We basically want this singleton where we're going to keep track of a Redis connection. And in order to connect to Redis, I'm going to get my credentials from this method called Redis creds. And what we can see that we're doing here for Redis creds is we're going to use this nice little utility in order to get the Redis connection information off of the environment. So I mentioned before that we should be able to get the configuration for our application off of the environment. That's one of the 12-factor principles. And then also another 12-factor principle is that you should connect to backing services over the network. They should be network attached, right? Attached services. Now here's the thing though. As an application developer, and even as an operator of a production environment, I never want to have to care where my Redis is located. I just know that when my application needs it, I just want to say, give me a Redis. So that's why I'm going to get the information off of the environment. So I never have to hard code it. There's no hard-coded password port or host here, and there's no weird YAML or XML configuration hidden up my sleeve. So you can see, nothing's here. So what I'm going to do is I'm just going to ask the environment, give me information about services that match the tags Redis and Pivotal. And if they exist, then my credentials will be fetched from that information. I'll get the host port and the password. If they don't, I'll just pass something empty, which will be the default. And incidentally, most Redis libraries, including this one for Ruby, will also read the environment variable Redis_URL, which is another way to pass this information on the environment. But that's how we're going to get credentials and access information to Redis, and I'll show you how that works in a second. But then here's my enterprise-grade analytics functionality. I'm going to track visits to my API endpoint. So every time we visit it, I'm going to increment visits. And then I'm going to emit visits as part of this JSON output as well. So this is like a web page tracker. This is just like the CGI you wrote in 1997 in Perl to track how many people came to your AngelFire page, which was definitely your NSYNC fan page. But it's cool because we're using really modern technology to do it. All right, so what I want to do is deploy this application. This is a new version. And I already have one version deployed, but as I mentioned before, we should have these immutable artifacts. So when I want to deploy this, I just have to type cf push again. Well, I want to show you one more thing. I almost forgot. The manifest file did change. I went from 20 megs of memory to 50 megs because more memory is always more enterprisey. And I also increased the number of instances I expect to get up and running whenever we start this thing up. And finally, I'm going to specify that I want to connect to a service whose label is CWES CFENV Redis. So I want to have this service, and I just want to connect to it. So here's what we're going to do. We're going to go ahead and push this application. So it uploads the app and the manifest into the stager again, and then it fails. And the reason it fails is that it can't find this service. Well, let's take a look at that. If I type CF services, you can see that we don't have any services available. So I need a Redis. So how long does it take you to get like a new backing service in production right now? Let's go with a month. Let's go with 3 months, 6 months, a year. Literally, I'm never going to get it. Yeah? A week? Yeah, some folks. A day? Cool, cool. Minutes? We have one with minutes. So we don't have Redis. So what I'm going to do is I'm going to look in my marketplace. This is a neat thing for services that are deployed onto Cloud Foundry. Each Cloud Foundry instance is unique. And one of the cool things about operating a Cloud Foundry instance is you can decide what services are going to be available to pick and choose a la carte for the developers who are deploying to your platform. So that's kind of neat. I'm running a really lightweight version here on my laptop, so I have 3 services: MySQL, RabbitMQ, and Redis. Again, this Redis is very important to my demo. And I have a few small plans of the ways that I can deploy these things. In a production-grade version of this, you'd be able to do HA clustered environments, but I'm running on my poor laptop, and I can't do that on my poor laptop. But I can get an instance of Redis. So the way I'm going to do that is with create service. So I'm going to create a service of type Redis. The plan I'm going to use is shared VM. And what's interesting about this is that this particular plan will use that lower level infrastructure automation to automatically create a virtual machine for me whose responsibility is to run Redis instances, right? Which is handy because I don't actually care about my machines and I don't really want to care. They'll be isolated from one another and that's good. And then if I need more, it'll just automatically fail over. So let's go ahead and create it. And now we're done. We have Redis. And if we type CF services, we can see again now that we do have an instance of Redis. But this is something that is a little bit concerning to me. Under bound to apps, you can see there's nothing. So this is a very lonely, isolated Redis instance. It can't talk to anything at all. No applications can talk to it. Because creating things and binding to things are 2 separate actions, which is pretty helpful because you don't always create new services. You're very often binding or connecting to existing services. So what we can do here is bind our application to our service, which is done. And if I type CF services again, you can see that our application is bound, which is nice. Now, the only way that you can influence the environment variables that are passed into instances or even processes on Linux is when they start up. So we currently have 0 running. So I want to start some new instances because I YOLO'd this into production and totally messed it up. That's why we have 0. But I want to show you what the environment looks like. And if you have permissions, you can do this with the cfenv command. And this will decrypt and provide to you the payload that's going to be provided to our application instances. So you can see that under this environment variable vcap services, we have a JSON payload where a key is Redis, and then we have these credentials: host, password, and port. Now you'll notice that whenever I said run Redis, I didn't specify a host name. I didn't specify a port. It just figured that out for me, and I didn't really care. You'll also notice that whenever I bound my application to the service, I also didn't care about it there. So this was just automatically handled for me. When I bound the app to Redis, though, it also generated a password for me, which was helpful. Because again, no human being should be involved in the generation of passwords. So it generated this password for me. Now what's neat about that is, who here is really excited by cycling credentials in production between applications and services on a regular basis? Everyone should be raising their hand, but I only see 2. That's fine. So if you're into that, one neat thing about this type of environment where this automation is already sorted out is that if you want to cycle credentials, you can just unbind the service from the app and then rebind it again. You get a new password. Just restart your application, and you can do that with a rolling deploy as well. And you're good to go. New credentials, no big deal. But I do want to get this app up and running, so I'm just going to go ahead and push it again. Now that the app is bound to Redis, we should see a slightly better outcome. And we can see that, again, it's going to create a brand new image. So this is a subtle difference, that we don't use layered file systems to sort of build up a version history. We build a completely new container. It's completely isolated and separate from the old one. And that way, sort of the immutableness is very, very clear. But we should get a few instances up and running here, and we do. And if I reload, we can see that visits is incrementing, instances is still cycling, and that's pretty nice. So that's good. I think there's one more thing that I want to show you about this, though. When I did this deploy, because in a cloud-like environment, of course, and if you're working with containers, you know this, there's no such thing as sort of update in place, right? You don't update or patch some environment in a server and then restart a thing. There's only destroy and create, right? So because of that, though, your typical push will destroy the existing running versions of your application and then spin up your new ones, which of course leads to downtime, and nobody likes that. So who here is practicing like zero downtime or BlueGreen deploys right now? And you'll know that like there's a lot of stuff to orchestrate in order to do that, especially if you're going to do it automatically, but even manually. There's a lot of work to do there. But I want to show you what BlueGreen deploys would look like with Cloud Foundry. In this case, we have this application that connects to a backend service. And if you're going to do a BlueGreen deploy, the way this works is, you've got a running set of instances of your application A, and you want to spin up running instances of your application B. And if that works, you want to cut traffic over from A to B seamlessly without any downtime, right? But in order to do that, you have to be able to manipulate the routing information and the load balancer automatically and live without any downtime. You also need to be able to manipulate the access between your application and its underlying services. So in order to do that, there's a lot of stuff to orchestrate. In Cloud Foundry, that's about 5 or 6 CF commands that you could run on the command line, but there's also a really nice plugin called Autopilot that I have downloaded, which makes it really easy to do a BlueGreen deploy, which is kind of cool. So what I want to do here in order to demonstrate this is down here, I want to run a curl command. So here's what I'm going to do. I'm going to make a loop. So while sleep1 do curl cwest.cfenv.local.pcfdev.io. I'm going to echo at the end because this JSON API endpoint does not emit a new line, and that drives me absolutely insane. And we will do done. And if we do this, we'll see that we're hitting our various instances and that our visits are incrementing. So not that I'm into like programmatically hacking the number of visits to my NSYNC fan page, but if I was, like this is definitely a good way to do it. So that's good. But here's what I also want to do. I want to show you this other thing that happens. Hang on. There we go. So with Cloud Foundry and with most systems, you can manipulate the routing information separate from the applications. So the route to my application is its own entity, a first-class citizen that you can manipulate, and that's separate from the apps. But we haven't really seen that very much. But if I type CF routes, you can see that I've got this route. It's in this space. It's got this host name tied to this domain, and it points at this particular application. And that's cool. So what I want to do is I actually want to watch this CF routes to see what's going on with our routes when we do something like a zero downtime deploy. The next thing I want to, I don't want to do that. Next thing I want to look at is the services, because we mentioned that we've got these bound apps to this Redis instance. Well, I kind of want to keep track of that. Let's see how we do here. So I'm going to watch this as well. And the final thing that I want to watch is apps, because we have an application running, but I kind of want to see, again, what happens when I deploy with zero downtime. I should end up having 2 applications running, and probably simultaneously for a little while. So I'm going to use watch again to look at my apps. So I currently have 6 instances of this thing running. Let's give ourselves a little more space here. If anyone wants to give me a crash course on how to programmatically manipulate iTerm in order to change these, or with command line utilities after this talk, that would be totally rad. Okay, here we go. We're going to get there. Okay, so I want to do a zero downtime deploy. Now, if I just deploy what's already there, you won't necessarily notice if it's zero downtime. So I'm going to do a little bit of live coding. I mentioned that when I live code, it's usually a bug, and that is totally true, but let's give it a shot anyway. Actually, let's not do a new service. Let's add to this. We'll say the cities, and we'll emit beer. That seems right. Okay, cool. Is that good? Okay. Where are my pair programmers at? No, we're good? Okay, you signed off on this. Okay, so I want to use this autopilot. So what I'm going to do is I'm going to do a zero downtime push. And I have to provide a couple of parameters here. I need to specify the application that I want to have zero downtime push on. That's the name of the app. I need to specify the manifest file. That's pretty important. And also the path to the application, which happens to be this current directory. So if we do this, ideally, we'll have what we call a zero downtime deploy. Now we can see that we now have 2 applications running. It renamed our existing one. And also, it's starting to stage and deploy an application with our ideal name. You can also see that both applications are bound to this route, so they can both service this route right now. Of course, the load balancer knows that there are no application instances running in our new one that actually work, so it won't route to it yet. And then the same thing with Redis. Both applications are bound to Redis. And now we did a zero downtime deploy, and we have our change here, which is nice. So that's cool. We did a zero downtime deploy. We still have 6 instances running, and we had no downtime. That's pretty handy. And we orchestrated all of these things in parallel. Well, not in parallel, but in the right order, we'll say. So that's cool. And now we've demonstrated most of these capabilities. I think the only thing that I really want to dive into a little bit more is the concept of health management, monitoring, and recovery. What happens, and I don't do this, and I know you don't do this either, but what happens if an application developer writes a bug? And what happens then if that bug actually makes it into production? Again, I know none of us have ever done this in our lives, and we don't even work with people who would do this. So I know you've probably only read about it on the internet. But sometimes an application workflow might even crash your app. So let's see what something like Cloud Foundry or a mature production environment would do to handle that. So what I'm going to do is, I'm going to back out this beer emoji. That they didn't like that in production for some reason. And I'm going to write a new endpoint called ouch. And I'm going to simulate this idea that maybe we're going to crash the app because we just did something bad and it crashes our app. Just simulating it. That should probably crash our process, right? That's probably not good. That's actually a pretty bad bug. But let's go ahead and deploy that to production. We'll go ahead and do our zero downtime deploy again, because why not? And so I'm curious about what happens to our application in the event that we have this bug. And especially if a user hits this bug. What I'm hopeful of is that the platform itself will err on the side of uptime and try and do its best for me to keep things alive. So we're doing our deploy. Things are looking okay so far. I'm just going to go ahead and stop these and kill them to clean up my space a little bit. There we go, another zero downtime deploy. That's pretty handy. And I think what I'm going to do here is I'm going to go ahead and let that keep going. And I'm going to watch the state of my applications here. So you can see that I've got 5 or 6 instances running here. Here they are. Make that a little bigger. So I have 6 instances running. So what happens to our happy path that we're constantly hitting down here if we were to go to, say, coscfenv/ouch? So if I go here, this request gets a bad gateway, and that would be expected. Before we were able to submit a response, we crashed our application, right? So that kind of sucked. So we got 502 bad gateway. The router that's built into Cloud Foundry did its job. But I'm going to go ahead and reload. And if I do, you can see that instance number 1 was starting again. Because it was crashed, the platform noticed that and immediately spun up a new one in its place. You'll also notice there's no service degradation. I'll crash a few. And you'll see that the router is also, the load balancer is also noticing or being informed of this information, and it's making sure that it doesn't route requests to crashed instances. But of course, once those instances come back, they're added back into the pool. All of this is done automatically. This is pretty cool. You can, of course, I only have 6 instances running, so if I refresh a lot, I should be able to crash all of them. And eventually I do get to a state where I have service degradation, but you can see that it recovered pretty quickly as well, which is nice. So this is sort of the state of the world if you've got this automation already completed. This is some of the harder stuff to fully automate in a production environment, but it's not so bad. So I just kind of wanted to show that. Again, I wanted to use some open source tech, so I used Cloud Foundry to show that, that minimum viable platform strategy. Oh, there's one more thing I wanted to show you. So, yes? Oh, yeah. Yeah, so if you crash an application instance enough times, it will do exponential backoff on trying to spin it back up because it's not a masochist, and eventually Cloud Foundry will be like, we got to cool off because maybe this application is really bad. But you can see that they're running now. Yep, no worries, and good catch. GitHub's going to buy you a beer. I'll deliver it to you, though, so it'll look like it came from me. Yeah, all right. So I've been deploying applications, and I haven't really been worrying about how the containers are built. But if you already are doing your own container build, and you're building cloud native or 12-factor apps now, you might still want to deploy them to something like Cloud Foundry, which you can totally do. So I have also packaged this application into a Docker container at kcwest/cfenv docker, which we should be able to see somewhere on Docker Hub. I can never remember the URL to it because I don't interact with it a ton, but it's there nevertheless. All right, well anyway, what I want to do is deploy that. And just to give you an idea, by the way, like here's a Docker file that sort of does all the grunt work for building the environment for this application. I actually want to run it in Alpine. On Cloud Foundry, all of your applications will, by default, run in an Ubuntu environment. But I like Alpine Linux. Who's into Alpine Linux? Yeah, a few folks. So I like Alpine, so I want to run that. And thanks to the magic of containers, my host machines don't have to care. So what I want to do is basically install Ruby, run bundler install, or install bundler, put my app in the container, run bundle install, and then tell it how to run my app. Pretty easy. So what I want to do here to run this application then is I can do a cf push just like before. You'll notice that I'm not in my application directory anymore, but I can specify the name of the app I want to deploy to. I have to specify that on the command line. Then I can use the -o flag, which happens to be a container image, and I can do kcwest/cfenv docker, and I've made labels that happen to correspond to my branches, which is just kind of helpful. So I'll go ahead and deploy the master branch. And what this is going to do is download the container from Docker Hub. You can also download from private repo or private registry if you want, but it's downloading it from the public Docker Hub, and it's going to stage it and run it. So now I'm running an instance of this app, and if I load here, you can see that this is cfenv docker, and if I do cf logs, cfenv docker, we should see some logs. Yep, I can scale it just like I did before. Let's do like 3 instances. And then you'll see that it's load balanced. We still have our logs, and that's all good. I can even do, I can go ahead and bind this application to, say, the existing Redis instance if I want to. So let's bind this to cwest cfenv docker, or Redis rather, which is fine. And then I'll go ahead and redeploy, but I'll deploy enterprise features. That's total party foul. I got to take a drink of my beer now. And now it's going to install that and run that. And let's see, if I reload, we can see our instances are incrementing. We happen to connect to the same Redis as before. Our visits are incrementing, and our instances are still cycling. So we can get all of the same operational characteristics, whether we're using Docker containers or the Cloud Foundry format. It does not matter, right? So your container format is way less interesting than whether or not you've got an operationally mature environment to run those containers in. That's my hypothesis, and I hope that you walk away with that. But if you want to rock Docker on Cloud Foundry, that's 100% supported and super fun to do. So almost done here. In about 45 minutes, I deployed like, I don't know, a bunch of times and auto-created, backing services and did all kinds of cool stuff that I thought was pretty nice. And I do get this question a lot. How much prep work did you do in order to make that demo go smoothly? And literally the answer is I vagrant upped the lightweight version of Cloud Foundry, and then I made sure I was on the right branch of my demo application. That's all I did. Everything that you saw came out of the box day one, just as a heads up. So why would we do something like this, or why would we need something like this? Well, I like this concept of cloud-native operability, right? If we're going to go with this cloud-native concept, I think operability is really important. And it's not just about the software you're operating, but also about the business you're operating, the stuff you're trying to do. So you need microservice architectures, right? Like we've at least basically decided that decomposing your application into smaller focused services is good for your operational scale and for your software scale, but it's also really good for your business, for your organizational scale. Like you can do the two-pizza teams thing if each of those teams can focus on smaller services. We do need to automate our delivery process. If you're going to do the microservices thing, you really need to automate your delivery process. And you need to have a good culture. So like the DevOps culture is the good culture. But in order to do this, I think in order to achieve successfully with microservices, continuous delivery, or DevOps, you really need a very operationally mature environment in production in order to deliver your applications to. And you don't have to use Cloud Foundry at all. Like you can walk out of here and never use it, and that's totally fine with me. But you do need those operational characteristics, and I would call that a platform no matter what you use. And it really does need to be there for you as the foundation in order to get a good environment for a good culture, process, and architecture. So we can be friends on Twitter. That's @CaseyWest. We can also be friends in real life. That's what that beer emoji is for. We can drink that beer. Maybe not exactly that beer, because that beer is an emoji, but we can drink a beer. And thank you very much for your time and attention. And I think we're going to turn it over to Kenny now.